All right, converting to SI prefixes or from SI prefixes or in between two different SI prefixes. So example one, let's say we have a number 37,042 and we want to make that, and it's a number of meters, and we want to make that an SI prefix or rewrite this using an SI prefix. Well, one way that you could write this number is scientific notation. So that would be 3.7042 times 10 to the, and how many times did I move the decimal? 4. These are the same measurement. Now, if I look in that prefix table, or the number line up here, the closest power of 10 to 10 to the 4 looks like it might be kilo. So I could choose kilo to rewrite this. But kilo is 10 to the 3, not 10 to the 4. So if I want to make this some number of kilometers, I've got to rewrite this number one more time so that it has a times 10 to the 3 here. So I can just replace it with kilo. That would be 37.042 times 10 to the 3. Just don't move the decimal so many times. Now it's really easy to go straight from the number that I have into kilometers, because I just drop this times 10 to the 3 part and replace it with K. So 37.042 km, kilometers. That number is the same thing as all three of these numbers over here. Every one of these numbers is really the same measurement. It's just a different way to write it. There's no one right prefix to use in any situation. It's just whatever you think is most convenient for writing that number. So I did it in kilometers, but I could have done it in megameters. If it was megameters, let me show you what that would look like. 37,042 meters. And I want to use mega, which is 10 to the 6 right here. I want to use mega to write this. Well, mega is times 10 to the 6. So if I started moving the decimal over 1, 2, 3, 4, and I want to end up with a number that's something times 10 to the 6, I have to move the decimal place 6 times. So 1, 2, 3, 4, 5, 6. Put the decimal, there needs to be a 0 there. So this would really be 0.037042. Let me rewrite it. 0.037042 times 10 to the 6. This number is the same as all these other numbers over here. Or this measurement is the same as every one other measurement I've written so far. But I can rewrite it 0.037042 using the mega prefix. I can just replace the times 10 to the 6 with mega. Why would you do that? Maybe you're trying to compare it to some other set of measurements that are in megameters, and it's really hard to compare unless you have it in the same prefix. I wouldn't just naturally choose, because it's not in the millions. Mega is 10 to the 6 or millions. It's only 37,000, so that's not what most people would reach for at first. They might think I could rewrite it with kilometers, but there could be a reason why you want it in megameters. It's completely up to you what prefix you write a number in, and you kind of have to get fluent in writing a number in whatever prefix is most relevant for the situation. All right, let's see another example. So that was going from a measurement that's not currently in a prefix and writing it with a prefix. So what if you do have it written already in a prefix, like 42 micrometers, and you want to write that without a prefix at all? This is a pretty easy process. All you have to do is figure out what power of 10 your prefix means. Micro means 10 to the negative 6. And literally just replace the prefix with that. So 42 times 10 to the negative 6 meters. and you're done. You could stop there. It's 42 times 10 to the negative 6 meters. What's that mean? Well, there's a decimal, there's 4 zeros, and then a 4 and a 2. It doesn't really matter that the 42 is bigger than 10. I think a lot of people get hung up on if the number in scientific notation right here is bigger than 1 and less than 10. It doesn't, I'm not going to ever penalize you for writing a number like this. But if it was in official scientific notation, you could write it as 4.2 times 10 to the negative 5 meters. All right. The third example is if you have a unit that's in a prefix already, or a measurement using a prefix already, and you wanted to write it in a different prefix. So 34.72 exaseconds. And I want to write that in milliseconds. Well, I would go look at the chart, figure out what exa and milli are. Here's exa. It's 10 to the 18. Milli is 10 to the negative 3. How many of the smaller unit fit into the bigger unit? 10 to the 18, 10 to the negative 3. So I'm dividing the bigger one by the smaller one to see how many of the smaller ones will fit. That turns out to be 10 to the 18 minus negative 3, which is 10 to the 21. So there are 10 to the 21 milliseconds in 1 exasecond. Well, I'm already in exaseconds, and I've got 34.72 of them. So if one of those is 10 to the 21 milliseconds, then I can just multiply that. 34.72 times 10 to the 21, and now it's in milliseconds. So I kind of skipped writing out the dimensional analysis, but you could. Let me show you what that would look like. If I wrote this like a dimensional analysis problem, you would start with the measurement, you would multiply by a conversion factor. I see exaseconds, so I need to cancel that. My conversion factor that I figured out in the box up here is one of these is 10 to the 21 milliseconds. Exaseconds cancel, and it ends up just telling me to multiply. This times this is that. That's all the things you really need to be able to do with SI prefixes, and the more that you practice with these, the more natural it will come to you. And you may still be a little bit rusty also with scientific notation and quickly changing forms of numbers, but we'll get there. Toodaloo.